Hello, my name is Chris Crossan with AVS Serial Systems, and today I'd like to introduce one of our latest products, the MPix13 megapixel IP camera. It is currently offered as an indoor dome model and an outdoor torpedo model. Both designs have 1.3 megapixels, Sony Progressive X view, day-night functions, and the outdoor torpedo model also has a 3 to 9 millimeter varifocal lens and infrared. In this video, I want to show some of the advantages of the MPix13 megapixel camera, and the first is resolution. Right now, the best recorded resolution you can get on a DVR is at full D1 at 720 by 480, which is shown here. The MPix13 has a resolution of 1280 by 960, almost 4 times as many pixels as the full D1. This also allows for a greater area to be covered with one camera with greater clarity. It would take 4 analog cameras to capture the clarity and the amount of pixels from just one MPix megapixel camera. The MPix13 also has a digital zoom function with included software. However, with a higher resolution, you do not get the heavy pixelation as you do on a DVR. Another major factor in image quality, especially with moving objects, is whether the camera uses progressive scanning or interlaced scanning. Interlacing divides the lines between even and odd, and then alternately refreshes them at 30 frames per second. This slight delay between the odd and even lines creates distortion or jaggedness, as seen here. Interlacing works well with CRT monitors. However, in our digital age, an alternate method has been developed, which is progressive scanning. Progressive scanning scans the entire picture line by line every 16th of a second from top to bottom. Progressive scanning is now the standard for most digital TVs and all LCD monitors. As you can see in this example, the jaggedness or distortion is removed. Even at high speeds, such as a car moving at 30 miles per hour, the image is not distorted. This first example shows interlaced scanning, where the face is not recognizable, nor the sign in the car window. The second example shows progressive scanning with our MPix13 megapixel camera. Even zoomed in, the face is recognizable, along with the sign in the window. Another advantage is direct converting. Most IP cameras are an analog camera and a video server just in one box. They are based on an analog camera and a video encoder that converts it to an IP signal, which causes significant video loss. The first video loss occurs when the camera converts the CCD's digital signal to analog, and the second video loss occurs when the video server converts an analog signal back to digital, as seen on the graph. A quick way to see if an IP camera has this conversion process that causes significant video loss is to see if the camera has an BNC type connection along with a network connection on the camera. The AVS MPix13 megapixel camera doesn't convert the CCD's digital signal to analog. It converts the CCD's digital signal directly to IP so that the video quality is preserved as shown on this graph. The last feature I want to point out in this video is the X-Wave Pro CCD with the light funnel technology. In the past, IP cameras had problems capturing a good quality picture in a dark environment. With the X-Wave Pro CCD and the light funnel technology, the sensitivity of the CCD to light is 4 times greater than an average camera. And this is done without slowing the shutter speed of the camera as a digital slow shutter camera. Here we see 2 images, the MPix13 image to the left and a digital slow shutter camera to the right. As you can see, the image is not distorted because of slow shutter speed as on the digital slow shutter camera.